Welcome back to another video from Insectech's Android Application Penetration Testing course. In this video, we're going to discuss broken cryptography attacks. So broken cryptography attacks are majorly categorized into two categories. The first one is if your application is using a process behind the encryption or decryption that is fundamentally flawed. In this case, no matter how strong your algorithm may be, you are vulnerable as you are not using the algorithm properly. So an attacker can actually easily exploit it and decrypt the sensitive data. And the second one is using a weak algorithm which is known to be vulnerable. So in both the cases, your application is vulnerable to this broken cryptography attacks. So let's see some more details about these two categories. So if you see this, the first one is poor key management processes. Let's say you are using a very strong algorithm, but the key that you have used to encrypt the data is kept in the same directory where the encrypted content is placed, or if your key is hard-coded. So though you have used a very strong algorithm to encrypt the data, you have given the key to the attacker so he can easily decrypt it and compromise the data. So that's one fundamental flaw that we see that we usually see in Android applications. And the next one is creating custom encryption protocols. So we have a lot of standard encryption protocols. We can use them, but some developers develop their own, custom encryption protocols, which leaves the applications vulnerable. And the last one is using insecure algorithms. Let's say you are using an algorithm like MD5 SHA-1. They are known to be broken. So if you are using them, again, an attacker may be easily able to exploit your application and gain access to your sensitive data. So let's have a quick demonstration of one example among these three. I'm going to use this insecure algorithm example. So for this, let me quickly launch my challenge 6 application. In this particular demonstration, we are going to see something new, which is I'm going to use a tool called APK tool. So before going ahead and using this APK tool, let's first install this challenge 6. I have already installed it, so let me launch this application, which is challenge 6. As you can see, this is the application. Now if you observe this, it is asking me for a password. Let's say click login, it says wrong password. So I am assuming that he has actually hard-coded the password inside the application itself. So let me quickly go ahead and see how this particular application is developed. So to do that, I need to have the source code. But let us assume that we do not have access to the source code, but all we have is an APK file. So in this case, we can use a tool called APK tool to actually decompile this application and have a look at the smally code of this particular application. If you are getting confused about what this smally code is, you just wait for M10, which is lack of binary protection. In this particular section, we'll discuss reverse engineering concepts of Android applications. So better if you are getting confused with this particular demonstration, I suggest you to go to this particular lack of binary protection video and watch it, and then come back to this broken cryptography so that you'll easily understand what we are doing here. So that's the reason why I'm not going to get into too many details of reverse engineering here, because we have already discussed them in this lack of binary protection. So let me quickly open this. We are currently inside this directory. So let me quickly go back and go to tools, APK tool. As you can see, we are there in that directory. Now what I'm going to do is I'm going to decompile this challenge6.apk file using this apk tool.jar. So to do that, java -jar apk tool.jar, use the switch D, which stands for decompile, and give challenge6.apk file to this particular apk tool.jar as input. Now if you observe, it is backsmiling and it has created a new folder called challenge 6 with the same name. Now let's quickly open this up, and if you observe this, we have Android manifest.xml file, Smally and res. If you observe this res, we'll have all the resources as you observe, as you expect. And if you go to this smally com.ist.challenge6, looks like it is the package name which is decompiled. Inside this we have main activity dot smally, and if you observe this, of course it is something like your assembly language, but not assembly language. You won't get the exact source code of your application using this APK tool, but you will get smally code, which is very useful for us in some attacks. Right, we'll discuss them in M10, lack of binary protections. Now if you observe, it is looking like this particular application is using SHA-1 algorithm. Just to confirm that, yeah, there is a hash. As you can see, there is a hash we got. Now you just copy this particular hash and go to any one website, let's say this website, and before doing that, let's calculate the length of this particular hash. As you can see, this is 40, which is obviously SHA-1. So this guy is using SHA-1 hash, and we got it from the source code by decompiling the application using APK tool. Now if you just give this SHA-1 hash here and click decode, fantastic, we got the password, and the password is password. So let's quickly go ahead and enter this in the application. Fantastic, it says success. So this is how one can actually exploit your application if you are using weak encryption algorithms in your applications. So if you just want to have a quick look at the source code of this particular application, let me show that. IST vulnerable application and challenge 6 source IST main activity. As you can see, this is what exactly we have seen in this particular smally code. SHA-pass, it's a string, and this is the password. He has hard coded using SHA-1 algorithm, and this is what exactly we have copied. And when the user enters the password, he is again generating a SHA-1 hash, and he is actually comparing it with this particular hash which is there in the source code. So if these two are matching, he is actually allowing the user to log in. Otherwise, and you can see this, he is now generating a SHA-1 hash and comparing it with the existing hard-coded hash. So if you are using weak algorithms, even if your content is encrypted, they can be easily broken. And in this demonstration, I have even used a weak password. So my password is weak, my algorithm is weak, so my application itself is weak. Right, so that's all I have in mind for this video. Thanks for watching it. Thanks a lot.